The only question you need to ask yourself while studying the third law is, what happens when two objects interact with each other? What happens when you place an object on the table? The object exerts a force on the table and the subject exerts an upward force on the object. There are two forces that result from this interaction: a force on the table and a force on the object. The magnitudes of the two forces are the same, but the directions are opposite. These forces are called as action and reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. What we saw here is nothing but a display of the Newton's third law of motion. Every action has an equal and opposite reaction. That's how simple the third law is. Every action has an equal and opposite reaction. It means that when two objects interact, there is a force on each object. The magnitude of force on the first object equals the magnitude of force on the second one. And what about the direction? The direction of force on the first object is opposite to the direction of force on the second one. Let's talk about more examples.
While the frog is swimming, it pushes the water back, and the water pushes its body forward.
Another example is walking. The ground and your feet interact. You pushes the ground backward and you push it and it pushes you and makes you go forward. The force your feet exerted is equal to the force the ground exerted.
As you sit in a chair, your body acts on the chair with one force, and the chair acts on your body with another force.
Hammering the nail is also an example of law of interaction. The hammer pushed the nail, which is the action. As a reaction, the hammer experienced a force coming from the nail.
When the ball hits the ground, it exerts a downward force on it. By the third law, the ground must exert an equal and upward force on the ball. The ball bounces because of the upward force exerted on it by the ground.
First, inflate the balloon. Don't let the air come out.
Tape a straw to it so that one end of the straw is at the front of the balloon and the other is at the back. Insert the thread through the straw.
What makes the balloon forward is the mere action of the air moving backward. In this experiment, we can see the law of interaction. The skipping air is the action, and the movement of the balloon in the opposite direction is the reaction.